Assalamu alaikum. This is Nur Fatiha Tahiyat from CAC 360 section 8 team the Unnamed, and my ID is 1910140. In our lab project we have built a maze solving system. For this system we have used two sensors. One is ultrasonic sensor and another one is infrared IR sensor. So first of all, in this Arduino code we can see we have ENA and ENB. Both of the pins are connected to the Arduino board so that we can enable or disable our motors. After that we have 4 input pins: IN1, IN2, IN3 and IN4. Here the IN1 pin is for the left forward motor, IN2 pin is for the left backward motor, IN3 pin is the right forward motor, and IN4 is for the right backward motor. Therefore we have another 2 pin. This trig pin is basically for the it basically triggers the ultrasonic sound pulse, and this echo pin, it is an output pin which goes high for a period of time and which will be equal to the time taken for the ultrasonic wave to return back to the sensor. After that we can see another 3 variable. This IRL basically means the IR left sensor. It is connected to the Arduino analog 0, and this A1 is connected to the IR right, and this IRD or IR downward is connected to A2. Here we have taken some threshold values. For IR high we have set it to 240, and for this ultrasonic sensor we have set D high to 20, and we have taken some another variables, like for the ultrasonic sensor we have this distance variable, and for the IR sensor, 3 IR sensor, we have taken 3 variables. Therefore we can see a function in here. So inside this function we have a long variable which is the duration. So this duration is the ultrasonic sound pulse back time period, and after that we can see that we have set our trig pin to low. Then we have a delay for 2 microseconds, and after that we have turned our trig pin on, and then we will have a delay for 10 microseconds, and then we will again turn off our trig pin. So after this we will calculate our distance based on the duration we get. So this distance means that in 25 milli-Celsius degree temperature the sound will go, or the sound goes 340 meter per second. After that we have our forward function. Inside this forward function we will set our IN1 and IN3 pin high. This 2 pin corresponds to the left forward and right forward motor, so that with the help of this function our robot can move forward. After that we have our back function. Here inside this back function we can see that our IN2 pin and IN4 pin, both of the pins are set to high, and another 2 pin IN1 and 3 are set to low, or they are turned off. So this IN2 and IN4 pin, they correspond to left backward and right backward motor. So with the help of this function our robot can move backwards. After that we can see our right and left functions. So in case of right we have only enabled our IN1 pin, and in case of left we have only set our IN3 pin to high. So in this case our robot, with the help of these 2 functions, our robot can easily move rightwards or leftwards. Whenever we encounter any obstacle, this off function will work. This basically turns each of the pins low. That means our robot will not move to any direction. So that was it from my side. Happy New Year.
I'm Tahmin Ahmed. My ID is 1910149. Now I'm gonna discuss about the second part of Arduino code, which contains basically 2 functions of Arduino code: the setup and the loop function. And the first in setup function, the inputs are given in the echo pin, which eventually decide the output of the rest of the pins. ENA and ENB are used to turn the motors on, off, and controlling speed, and IN1 and IN2 pins are used to control the spin of the motor. IN3, IN4 control the spinning direction of the motor B. Now the serial dot begin 9600 means basically the baud rate is 9600 passes the speed parameter to the function. Now moving into the loop part, first line is sonar, which means it's a sonar function. First of all, the LRD indicates the leftward, the rightward and backward movement of the agent. So now it's time for the if else answer. If distance is higher than d height threshold, then it will move forward, and the serial pin indicate forward movement of the agent likely. If the L is lower than the IRD height threshold, then it will move to the left and the value will be -2. Let's move to if else condition. If the value of the R on the right is lower than the IRD height threshold, and it will move to the right, otherwise it will move to the backward. If all the conditions get failed, it will eventually get turned off and will give the output of 0.
I'm TM Sadrehan, and I'm going to explain the proteus part. Here we have used two kind of sensors. One is one is HCSR04, and the other is GP2D120. All of the things are connected to the motor driver, and the motor driver is connected to the Arduino, by the port T5 to T10, and we have also and here we have also the compine. We have also the compine, which is connected to the Arduino, which is also connected to the Arduino. And if we come to the circuit in Labview, here we can see the sensor, the sensor reading. Here we receive the input from the sensor, and we convert the data to the different method. It comes here, the direction part, and the direction is connected to the 4 different LEDs. How we can see when the data is 2, and it will go right, and when the data is 3, it will go forward, and the same is for the others. And when we run the project, probably as well, here we can see the initial initial values. Let me set it to the initial value. And when we run the Labview file, we can see the initial data over here, and the robot is not moving. And when we change the value, like if we increase the value of right, then we can see the robot is moving right, like this. And if we increase the value left, then we can see the robot is moving left. And when we increase the value back, we can see the robot is moving back. And when we increase the value up, then we can see the robot is moving forward. Thank you so much.